Municipal bonds have tax advantages. They are federally tax-free and sometimes state tax-free. We're just going to think about the federal taxes here. And so what we've got here is a relationship that tells us what the equivalent returns are for otherwise identical municipal and taxable bonds. The interest rate on the municipal bond is equal to the interest rate on the taxable bond times 1 minus T, where T is the investor's marginal tax rate. Now, the municipal bond is tax-free, and so anyone with a tax rate greater than 0 would possibly prefer a municipal bond. But to find out, we need to run through this calculation to make sure. And so this is often the way these problems are worded. An investor is in the 30% tax bracket. They have a choice between a bond that pays 10% before taxes or tax-free 8%. Which would they prefer? If they're paying 10% on the taxable bond, but then they have to pay taxes on it, they're going to lose 30%. They will end up with 7% being the tax-free equivalent. Well, if they can get 8% on a municipal bond, they would prefer that municipal bond paying 8% to the taxable bond paying 10%. And sometimes we're asked about it the other way. We're asked about the taxable equivalent yield, or TEY, which is another name for I sub t in our equation. And so we need to solve this thing for I sub t. And to do that, we are simply going to divide both sides by 1 minus t. Now note that the 1 minus t's cancel out, and we are left with the taxable equivalent yield being the tax-free equivalent yield divided by 1 minus t. We could have worked this the other way and said, what if we had our 8% divide by 0.7? And 8 divided by 0.7, let's see here. 8 divided by 0.7 is 11.43%. That would be the taxable equivalent yield of that bond. And since that is greater than 10%, once again we would see that we prefer the municipal bond. Now there's one more calculation that we could do here. We could be asked to find the marginal tax rate. And to do that, it takes a little bit more work. So first of all, we are going to have to divide both sides by I sub t. And when we do, we see that I sub t cancels out. And now we can subtract I sub m over I sub t from both sides and add t to both sides. And when we do that, we are left with t is equal to 1 minus I sub m divided by I sub t. Notice all I did there was subtract or add t to both sides. And when I do, it cancels out on this side and shows up over here as positive. I also subtracted I sub m over I sub t from both sides, and when I do that, it cancels out over here and shows up over here as a negative. And that's how we get our investor's marginal tax rate. Now let's talk about current yield. Current yield is one of the things that troubles students the most because they always look at this and think, aha, that means the yield to maturity at the present time. But that's not true. Current yield is its own thing. Current yield is calculated as annual coupon divided by bond price. And of course, we could do some different manipulations of this formula to come to find the bond price or the annual coupon. So let's go ahead and do that. Let's start with annual coupon. To do that, we just need to multiply both sides by bond price. What we're seeing here is that when we multiply by bond price, it cancels out leaving annual coupon by itself and becomes multiplied by the current yield. And so that is your formula for annual coupon. What if instead we were asked to find the bond price? What I've done here is divided both sides by current yield, leaving 1 on the left-hand side, and then multiplied both sides by bond price, which cancels out on the side with annual coupon, but leaves us with bond price over here. And so now we also have the bond price. So these are all of the iterations of this formula, except it's not quite true because there's one more thing we can do. Remember that annual coupon is just the coupon rate times the par or face value of the bond. And the bond price is the quoted price, which is in percent of face value, times par. And so we can substitute these back into our formula and see the following. And once we get to this step, we can see that the par value or face value of the bond cancels out, and we are left with current yield equal coupon rate divided by quoted price. Keep in mind these are both in percentage of face value. And so now you can rearrange this formula just like we did previously and find quoted price in terms of coupon rate and current yield, or find coupon rate as quoted price times current yield. Now let's talk about the Fisher effect, which gives us the relationship between nominal returns, real returns, and the inflation rate. Nominal returns represent the percentage return you're going to get in units of currency, whereas real return talks about your increase in your ability to consume. And of course, inflation is the rate at which prices grow. Now notice that I've got little h in here for inflation. We do not use I for inflation because you might get confused between that and interest rates, so we use h. You may see some people use pi, the Greek letter pi. And I found this confuses students to no end, and they always want to put something like 3.14 in for pi when they see it. And so I always just use h. Now, what can we do with this to solve it for each of the individual components? Well, the first thing we could do is to expand that right-hand side using the FOIL method. Let's talk about what FOIL means. First, outer, inner, last. So, what can we do? 1 plus big R is equal to, multiply the first two together. 1 times 1 is 1. Multiply the outer two together, and you get H. Multiply the inner two together, and you get R. And multiply the last two together, and you get RH. And so in this case, the 1's will cancel out, and you'll be left simply with big R is equal to, I'm going to reorder this a little bit, R plus H plus RH. Now you may see an approximate version of the Fisher effect that just is adding the real rate and inflation together. The reason it's approximate is because it does not account for this product right here. And this product becomes more and more important as R and H get larger because it becomes a bigger portion of our nominal return. And so my advice to you is only use the approximation when you are out at the bar after work talking to your friends about nominal return, real return, and inflation. But whenever there's true money at stake, always use the exact equation. Okay, now that we have big R, we could try to solve for the other two things. And it turns out it's actually easier if we go back to our original formula to do that rather than to try to work with this formula down here. So let's do that. Let's start by calculating the real return. To do that, I would divide both sides by 1 plus h. Okay, notice that I've switched sides there, but all I really did was divide both sides by 1 plus h. And so now we are left with 1 plus little r is equal to this fraction over here. And all I need to do to get little r by itself is to subtract 1 from both sides. Similarly, I could say 1 plus h is equal to 1 plus r divide by, that's a big R right there, divide by 1 plus little r. I can subtract 1 from both sides. And so these two equations are quite similar, and when you look at the formula, you can see why.